This question is palindrome partitioning. So the ask of the question is given a string S, partition it such that every substring of that partition is a palindrome, and then we return all possible partitionings. So what is a palindrome? It's any given substring that is read the same when we read it forward, and that is read the same when we read it backward. So AA is a palindrome, B itself is also a palindrome. So the first character is just a palindrome. Now the way it will work is we will use backtracking. We start from index start, and then we try every possible substring S. So from a start pointer all the way until that end pointer. Now if that substring is a palindrome, we add it to our current path and then recursively partition the rest of the string beginning at end. And now when the start reaches the end of the string, the current path is complete, so partition is valid. We save a copy, and then we backtrack. So we choose, explore, and unchoose our classic backtracking sequence, and then we reuse the same path list across all branches. So if you look at the code, we start with result and empty array. We declare a function palindrome, which means it takes in a substring, which I've called sub, and it will return true if the substring is read the same if it's read from left to right or right to left. So this is the syntax to reverse a substring. And then we start with our classic backtracking way, which means we take a path and then our current. So current is our current index. You can also call it start, and then we check if the current index reaches the end of the string, then we append it to a result. And then what are we appending? We are appending the path, and we are appending it as a copy. We return. Now in this for loop, one thing to notice over here is that we are starting with current plus 1 all the way to length of S plus 1. The reason why we are choosing current plus 1 is when we look at line number 13, we are making a substring that starts from current until our this chosen index over here, which is basically our end index. So if we do not choose current plus 1, which means this end index, if we just choose current, right, if we didn't do this plus 1, if we did not do this, then our this I, which is our end index, would be in the first iteration would be current. So that is 0 substrings, because from current to current is 0 substring, and that would not work. And that's why we choose current plus 1, because our smallest possible slice needs to be a single character. So in this case, our smallest possible slice will be current, and then your first I is current plus 1. So current to current plus 1 is your first substring. And then you go all the way until length plus 1, because even the second stop is not exclusive and you want to include the last character, so you go until length plus 1. Now you say if it's palindrome, you are going to check if it's a palindrome. If it is, then you append it to the path. What are you appending? The substring that you created. You backtrack, so you pass your path, and then you pass your I, and then you pop. You backtrack, call the backtracking function. You pass in 0 because you start with the 0th index, and then you just return the result.